Today we're going to be talking about solving absolute value equations. And remember that absolute value is essentially the distance from zero. So you have two answers when you are solving the absolute value of -4 and the absolute value of 4. You have a point that is -4, that's 4 units from zero, and +4, that's 4 units from zero. That's why when we solve absolute value equations, we're going to have two answers. Okay, our first example, evaluate that if x equals 4. So we plug in x equals 4. And I have 6 minus 8. So we have 2.7 plus 2, which becomes 4.7. Now solving equations. I have the steps written out there for us. Our first step is to isolate the expression in the absolute value sign. So we need to isolate this piece. That piece is being multiplied by 1/2, then 4 is being added to it. So what we need to do is we need to subtract 4 from both sides, that last thing that's happening to it. Because if you multiply by 2, a lot of you guys are going to forget to multiply the 2 to the 4. So we have 1/2 times -3 plus k equals 3. Now when we multiply by 2, we're going to have -3 plus k is going to be equal to 6. So I've isolated the absolute value sign. My next step, write two equations, one positive, one negative. Because this number's distance from 0, or this thing inside here, -3 plus k, can be equal to +6, or -3 plus k can be equal to a -6. So then we solve each one of those individual equations and we get k equals 9. And from this one, k is going to equal -3. So we have those two answers. And then if you plug those back in, those should both work in your equation to make a true equation. Okay, solving this equation. Again, first we need to get rid of what's being added or subtracted to this absolute value piece. So we need to add 1 to both sides. So we have 3x minus 4 all over 4 is equal to 10. Now get rid of the 4 on the bottom, so I multiply both sides by 4. That cancels out that 4 on the bottom. So we have 3x minus 4 is equal to 40. Now set up your two equations. 3x minus 4 is equal to a +40, or 3x minus 4 is equal to a -40. So I add 4 to both sides. X is going to equal 44 over 3. If I add 4 to both sides with our negative, we get -36. X is going to be equal to -12. So we have our two answers. Next example. Again, isolate this absolute value. I subtract the 5 over. Now be careful here. Remember, this absolute value piece is always positive. You have that equal to a negative number. That's never going to happen. So here we have no solution. no matter what, I'm never going to find a value of t that's going to equal a negative number, because whenever we found absolute value, that's going to be equal to a positive number. And you could always write no solution like that too. Okay, notice in this example how we have a y on both sides. It's very similar to ones we've been doing. We have 8 plus y is equal to the positive version, and 8 plus y equal to the negative version. So I'm going to solve the first one on the left. I'm going to subtract the y over to get y. I'm going to add the 3 over to get 11. Now they give me a little hint. They say check your solutions. So plugging in 8 plus 11, the absolute value of that, does that equal 2 times 11 minus 3? So this is 19 on the left side. I have 22 minus 3 is 19, so that works out. So this is one answer, so I'm going to circle that. Our next one, I'm going to distribute the negative to both terms. Now I'm going to add this 2y over to get 3y. I'm going to subtract the 8 over to get a negative 5. Now I'm going to check this. 8 minus 5/3. Is that going to be equal to 2 times negative 5/3 minus 3? Well, 8 is 24/3 minus 5/3. That's going to be 19/3 on the left. On the right, we have negative 15/3 minus 3. I'm sorry, not 15, that's 10. We have negative 10/3 minus 3, which is 9/3. So we get negative 19/3. Obviously, a positive is not going to equal a negative, so this is what we call an extraneous solution, so our only answer is 11. Now that's not always going to happen, but a lot of times that is going to be the case when you have a variable inside the absolute value and outside the absolute value. Okay, our next example. Martin makes exercise weights. For his 5-pound dumbbells, he guarantees the actual weight of the dumbbells is within 0.015 pound of 5 pounds. Write and solve an equation that describes the maximum and minimum weight of his 5-pound dumbbells. Now this is a absolute value equation. The central value is placed inside the symbol, and the range is placed on the other side. So if you think about it, what is our range? What is he guaranteeing they're going to be within? He's guaranteeing they're going to be within 0.15 pounds. What is the central value? Or the value that this range is going to come off of, that's of 5 pounds. So we're going to have x minus 5, our central value, equals 0.15. So now I have two equations. I have x minus 5 is equal to negative 0.15, and x minus 5 is equal to a positive 0.15. So x is going to equal, if I add 5 to both sides, I get 4.85. Oh, that should be a minus sign here. Now if I add 5 for this bottom equation, we get 5.15. So make sure you have units. I have my equation. I will be looking for the equation, and I've written and I've solved. So these are what he guarantees the weights to be between. There are your lesson questions. Please make sure those questions and your lesson summary and lesson question is submitted on time.